It is the year 1946, and a new era of technological advancement has dawned upon us. An era where the power to process vast amounts of information and complex calculations at lightning speed is now within our grasp. The abacus is one of the oldest known calculating devices, dating back thousands of years. It remains one of the most recognizable symbols of mathematical calculation. But despite its simplicity and effectiveness, it has its limitations. Deep within the British countryside, a top-secret project was underway to develop a device that would change the course of history. Coded Mark I, nicknamed Colossus. This pioneering machine was the world's first programmable, electronic, digital parallel computer. Faced with the daunting task of intercepting and decoding German messages, the team led by Commander Hugh Alexander and American mathematician John Camillo put their heads together. It opened up new possibilities for information processing and computation. He incorporated the principles and concepts demonstrated by Colossus in his design for the EDVAC, the successor to the ENIAC. The EDVAC was revolutionary. It featured a stored program concept, enabling it to perform a variety of tasks. Developed under the direction of mathematician John von Neumann, it was a massive machine weighing over 30 tons and occupying an area of 18 by 18 feet. The potential applications for such a machine were vast. Scientists, engineers, and researchers across various fields were eager to harness its power. Each program required the physical manipulation of thousands of wires and settings, limiting the speed and efficiency of operation. Researchers and developers around the world began exploring the potential applications of these machines, setting the stage for the digital age. Some questioned whether machines could truly replace human intelligence, and what ethical considerations needed to be addressed. The development of more powerful and compact computers became a priority for both sides. Companies began to emerge that specialized in developing and manufacturing computers for various purposes. The market for computers expanded rapidly, opening up new opportunities for businesses and consumers alike. Computers were still expensive, difficult to program, and prone to breakdowns. They experimented with new materials, architectures, and software solutions to create more efficient and user-friendly machines. The quest for smaller, faster, and more reliable computers remained a driving force behind innovation. The need to process vast amounts of data and control complex systems and space missions drove the creation of some of the most advanced computers of the time. These computers were not only capable of performing complex calculations, but they were also incredibly reliable and compact. Reliability and affordability were major concerns for many users. However, the determination to overcome these obstacles was unwavering. This tiny semiconductor device enabled the creation of smaller, faster, and more energy-efficient computers. Machines that were once the size of rooms were now small enough to fit on desks, opening up new possibilities for individuals. As computers became more interconnected, the risk of hacking and data breaches increased. This led to the development of cybersecurity measures to protect against malicious attacks. Home computers and later laptops brought computing power right into people's homes and offices. The invention of the transistor in 1947 marked a pivotal moment. Transistors replaced bulky vacuum tubes, leading to the development of more compact and reliable computers. Computers have become indispensable in various industries, driving efficiency, automation, and innovation. In finance, they ensure secure transactions, manage investments, and analyze market trends. In manufacturing, computers control robots, optimize production processes, and maintain quality standards. By the 1960s, computers were being designed with multiple integrated circuits on a single chip, paving the way for even smaller devices. Some focused on hardware, developing the physical components of computers, while others specialized in software, creating the programs and applications that brought these machines to life. They connect us through social media platforms, entertain us with streaming services, and educate us with online courses. The internet, which relies heavily on computer networks, has become a vast repository of knowledge and a marketplace of ideas. In healthcare, computers revolutionized the way patients were diagnosed and treated. Cybersecurity threats continue to evolve, demanding constant vigilance and innovation in protective measures. Striking a balance between technological advancement and ethical considerations is crucial. Ensuring privacy and ethical use of data remains a pressing concern. The journey from the first computers to the digital marvels of today has been nothing short of extraordinary. And as technology continues to advance, the future of computing holds even more promise. Their impact on shaping the modern world is immeasurable. The evolution of these machines has been nothing short of remarkable. The ENIAC, one of the earliest general-purpose computers, was a behemoth weighing over 30 tons. Its massive size and complexity were a testament to the ingenuity of the engineers and mathematicians who built it. From the towering room-sized giants of the mid-20th century to the sleek, powerful devices that fit in the palm of our hands today, computers have shrunk in size while expanding in capability. In finance, they transformed the way transactions were processed and investments were managed. In manufacturing, computers brought about a new era of automation and efficiency. This division allowed for greater innovation and efficiency as companies could focus on their core competencies. These handheld devices allow us to connect with people across the globe, access a wealth of information, and perform complex tasks with ease. The evolution from massive room-sized machines to pocket-sized wonders is nothing short of astonishing. The impact was monumental. Computers became more accessible, powerful, and versatile than ever before. Despite its incredible capabilities, it was small enough to fit in the cramped space shuttle. This competition spurred innovation and led to the creation of smaller, faster, and more efficient machines. These discussions laid the foundation for the ongoing debates about the role of artificial intelligence in society. The ENIAC's impact was profound. It opened up new possibilities for solving complex problems and pushed the boundaries of what was possible with technology. The ENIAC's unveiling was a momentous occasion. It marked a significant leap forward in the world of computing. This behemoth of a machine capable of performing complex calculations at incredible speeds was the culmination of years of hard work and dedication by a team of brilliant minds. Educational institutions began offering courses in computer science and programming, recognizing the growing importance of these skills in the job market. A new generation of tech-savvy professionals was emerging, ready to harness the power of computers to solve complex problems and drive innovation. Von Neumann's contributions laid the foundation for the modern computer architecture, influencing designs for decades to come. After the war, the British government decided to dismantle Colossus, keeping its existence a secret for decades. However, the impact of this technological marvel would soon be felt around the world. They pooled their knowledge and experience to develop Colossus. Working tirelessly in secrecy, they faced numerous challenges, including a shortage of skilled workers, limited resources, and the constant threat of air raids. The need for accurate and speedy calculations in various fields, including science, engineering, and business, had become apparent. Enter the Electronic Numerical Integrator in Computer, or ENIAC, the first general-purpose electronic computer. Yet they persevered. Mechanical calculators like the difference engine by Charles Babbage were groundbreaking innovations in their time. It was designed to break the German Enigma codes, a crucial turning point in the war. The Enigma machine, used extensively by the German military, was thought to be unbreakable, but Colossus proved otherwise. This electronic behemoth, standing nearly 7 feet tall and occupying an entire room, consisted of thousands of vacuum tubes and miles of wiring. It processed information at a staggering speed of 5,500,000 operations per second, far surpassing the capabilities of any human mind. They could perform complex calculations automatically, but they were slow and prone to errors. We are on the cusp of entering a world where machines can think, calculate, and solve problems that once seemed exclusive to the human mind. For centuries, humans have sought ways to make sense of numbers and symbols. By the beginning of the 20th century, it became clear that there had to be a faster, more efficient way to process information. A machine that could think and calculate at the speed of light. This desire for a faster, more efficient way to process information led to the birth of the first computers. In the midst of the Second World War, when Adolf Hitler's Germany dominated Europe with its seemingly invincible war machine, something remarkable was happening in the shadows. Developed in 1943 by a team of British scientists and engineers at Bletchley Park, Colossus was a marvel of its time. But building this technological marvel was no easy feat. Colossus was a leap forward that laid the groundwork for the modern computer. Its impact extended beyond the realm of code breaking. In the United States, mathematician John von Neumann played a pivotal role in advancing the development of computers. As the world grappled with the aftermath of World War II, the race to build better and more powerful computers was on. On February 15, 1946, the ENIAC was unveiled to the world at the University of Pennsylvania. The ENIAC's capabilities were nothing short of astonishing. It could perform 5,000 operations per second, a feat that would have been unimaginable just a few years earlier. However, despite its impressive capabilities, the ENIAC had its limitations. Programming the machine was a complex and challenging process. As word of the ENIAC's capabilities spread, interest in computing grew exponentially. Amidst the excitement surrounding the ENIAC, concerns were also raised about the potential implications of such advanced technology. As the Cold War era dawned, the race between the United States and the Soviet Union intensified. Meanwhile, the commercial potential of computers was not lost on entrepreneurs and investors. As computers became more prevalent in various industries, the demand for skilled programmers and technicians soared. Yet despite the rapid advancements in computer technology, challenges remained. As the years went by, computer manufacturers continued to push the boundaries of what was possible. And then came the moment that truly revolutionized the world of computing, the invention of the transistor. The space race of the 1960s further accelerated the development of computer technology. The Apollo guidance computer, for example, which guided the spacecraft to the moon, was a marvel of miniaturization. As the computer industry matured, companies began to specialize in different areas. But the true magic of computers lay in their ability to transform industries. The rise of personal computers in the 1970s marked another significant milestone. However, with the increasing reliance on computers, concerns about security and privacy also grew. Looking back at the journey of computers from their humble beginnings to their current state of sophistication is truly uninspiring. The first computers were not just tools for calculation, they were pioneers in a world where technology was in its infancy. As time marched on, computer manufacturers sought to create smaller, more efficient machines. Today we live in a world where smartphones are more powerful than the computers that guided us to the moon. The impact of computers on society has been profound. They have revolutionized the way we work, communicate, and interact with the world around us. In healthcare, computers assist doctors in diagnosing diseases, developing treatments, and improving patient outcomes. Beyond industries, computers have permeated every aspect of our lives. But as we revel in the benefits of modern computers, it's essential to acknowledge the challenges that lie ahead. Moreover, as computers become even more powerful, questions about artificial intelligence and its implications for society arise. Looking back at the first computers, those pioneers that laid the foundation for today's technology, we are reminded of the relentless pursuit of innovation and the transformative power of human ingenuity. As we stand on the threshold of a new era in computing, let us celebrate the achievements of those who came before us and embrace the exciting possibilities that lie ahead.